Hello, Algebra 1. As I mentioned yesterday, I'm not here today, but I wanted to make sure that you guys could still move on in some notes. So I recorded this video. I ended up trying to use a microphone, so hopefully the audio issues are a little better than last time I left you a video. If not, I apologize. Please just follow along the best you can. Okay, so yesterday we did adding and subtracting polynomials. And we did multiplying when it was just a monomial times a polynomial. So the difference today is that we're going to be multiplying polynomials. It says when you multiply polynomials, you are just using an extension of the distributive property. It's an extension of what we did yesterday. Every term in one polynomial must be multiplied by each term in the second polynomial. So just to kind of remind you of what the distributive property is, if you have A and you multiply it by B plus C, you end up with AB plus AC. That A goes to both terms. So when it's saying, say we have two polynomials, something like this, what happens is that A has to go to both terms here. So A has to go to C and D, and B has to go to C and D as well. And so you end up with A times C, A plus A times D, B times C, and B times D. That's kind of just showing how it extends what we did yesterday. You just have to make sure that every term in one polynomial gets multiplied by every term in the second polynomial. Oops, I just did the same thing for both. Okay, so it says when you multiply polynomials, it's an extension. So it says find the product of two binomials multiplied together. Remember we talked yesterday, the binomial is a two-term polynomial. Okay, so when they both have two terms is kind of what these first few are. I'm going to show you two methods, and I'm kind of going to go back and forth between them on the note sheet. There are kind of two methods I like to teach when I'm doing multiplication of polynomials. The first is the box method. And if you remember back in elementary school or middle school, you might have used the box method for like area. If you wanted to multiply like 22 by 43 or something, you might have said 20 plus 2 and then 40 plus 3 in a box, and then multiplied. So you get 4 times 2 is 8, and then 2 zeros. 40 times 20 is 800. 2 times 40 is 80. 20 times 3 is 60. And 2 times 3 is 6. If you add those up, 80 plus 60 is 140. So you're at 946. Okay, it was a way that you might have learned how to do multiplication like that before you did like the standard algorithm. So you add up everything and you get 946 there. The box method here is pretty much going off of that. That's what it's based upon, is basic, just algebraic, or not even algebraic, but simple multiplication area models, okay? So to do the box method, it says find the degree of each polynomial being multiplied and add 1 to the degree. So when I look up here, 2x plus 3, that's a degree 1. X plus 5, that's a degree 1. It says to add 1 to both to find the dimension. So 1 plus 1 is 2, 1 plus 1 is 2. The dimension then is going to be a 2 by 2 box. Okay, so I'm going to draw that box. I'm at step number 2 now. And I'm going to draw it up here because this is kind of where I have space. And along the side or the top, you're going to put the first polynomial, 2x plus 3. And then the bottoms, you're going to say x plus 5. And now you go through the multiplication. So in this first box right here, we're taking a 2x times an x, and we get 2x squared. In this box over here, okay, we're taking that we have a x times 3, we get a 3x. In this box down here, we get 5 times 2, a 10x. And then in this box over here, 5 times 3 is 15. What happens is that when you set them up, in a box, a lot of times your diagonals are going to have the same variables with them. So like you can combine those terms. So we'd say 2x squared plus 10 plus 3. So that would be 13x plus 15. That would be my final answer. So 2x squared plus 13x plus 15. Okay, so that's the box. That's kind of one method that I will use throughout the note sheet. Okay, multiply the polynomials, combine your like terms. The distributive method is like just if you like to just do it the distributive property way, kind of the way it's always been done, we can take 2x plus 3 times x plus 5. And what needs to happen is this 2x needs to be multiplied by both terms over here. So I'm going to write 2x and I'm going to multiply that by x plus 5. Then we're going to take that 3 and it also has to be multiplied by x plus 5. So this 2x gets split up from the 3, which is over here. You split them apart. And then this part, the x plus 5, stays together, but it's getting multiplied on both sides. So I say 2x times x, which is 2x squared, 2x times 5, which is 10x. Over here, we're on to a new kind of polynomial. So 3 times x, we would get 3x. 3 times 5 is 15. Okay, so then I combine these two because they have the same variable, same exponent, and I get 2x squared plus 13x plus 15. Now, it really doesn't matter to me what method you use. You just need to make sure that every term in one polynomial gets multiplied by every term in the second polynomial. Okay. So, letter B right here. I'm going to do the box for this one, and then I'll do the other method for the second 2B over there. Okay? So, here's my box method. I look at each term, or each binomial. I see that it's degree 1. And this one's degree 1, which if you're trying to come up with your dimensions of the box, it would be a 2 by 2 box. You take the degree plus 1. And so I get this little box here. Across the top, 4a minus 5. Across the side, 2a minus 9. I do my multiplication. 4 times 2 gives me 8. A times a gives me a squared. Negative 5 times 2 is negative 10. That has just been a little bit. 4a times negative 9, we get negative 36a. And then negative 9 times negative 5, we get a 45 there. Again, if we look at that diagonal, hopefully they have the same letter. That's the intention there. And so they do. We combine those like terms, 8a squared. Negative 36 minus 10 is negative 46a. Then we have plus that 45. Okay, so that's your box method. If you move over to 2b here, okay, we'll do this the other way, or I will set it up the other way. Okay, so again, this one is degree 1. This one's degree 1, which means it's going to be a 2 by 2. Oh, I lied. I said we were going to do the horizontal method, and here I am doing the box. So you don't even need to do that. Let's just break this apart. Okay, so this has to make sure to be multiplied to these two terms. And then this has to be sure to be multiplied by these two terms. So that 4b, break it apart. It has to be multiplied by 3b plus 2. That minus 5, break it apart. It has to be multiplied by 3b plus 2. And so, again, what we get, this one's broken up. You still keep that negative sign, though, on that negative 5, so make sure you watch that. The 3b plus 2 can kind of stick together. You're going to multiply through. So if I take 4b times 3b, 4 times 3 gives you the 12. B times b gives you b squared. 4b times 2 you would get 8b. Okay, move on to the next kind of grouping. Negative 5 times 3 is negative 15b. Negative 5 times 2 is negative 10. Combine your like terms. So 8 minus 15, we get minus 7. And so your final answer is 12b squared minus 7b minus 10. Okay? So if you don't have that written down, make sure quick to get it. Okay? So here was kind of an interesting problem that I saw. So it says a contractor is building a deck around a rectangular swimming pool. The deck is X feet from every side of the pool, which just means we don't have the exact number. What it says is write an expression for the total area of the pool and deck. Well, I look at that and I can see that it is going to be a rectangle. So the area of a rectangle is just our base times our height. So this would be like our base, this would be our height. And what we want to do, sorry about that, is go and put those h and b in terms of x. So my height of just the pool part is 15, or if we compare here, so this is the 15, and then we also have this x length and this x length. So my height is 15 plus x, okay? Because here's my x length, and then we have the 15. So the height is really 15 plus 2x. If I go and look at the base, this time, this part is 20, and then you also have the two x's here. So it'd be 20 plus x, or 20 plus 2x. Okay, so look at that. The x are for the two deck part of it. So it's x length on either side of the pool there. So to find my area, I'm taking my base, which is this right here. So my area equals my base, which is 20 plus 2x, times my height, which is that 15 plus 2x. Here it's just two binomials being multiplied together then. So you're just going to either do your box method, do your horizontal method, whatever it is that you want to do. It's just another 2 by 2 one, 20 plus 2x, and 15 plus 2x. 15 times 20, we end up with, I believe, 300. 2x times 15, we get 30x. 20 times 2 is 40x. 2 times 2 is 4x squared. And so it wants our area in terms of x. So we say 4x squared. 40 plus 30 is 70. And then we have 300 there. Now it doesn't matter. You don't have to go from the highest degree to the lowest degree. It is just what I'm used to. So I always go from highest degree to lowest degree. Okay. Now, if you look at this next section, before it said binomials, so we always had two-term polynomials being multiplied by two-term polynomials. Here, we're going to mix it up. There's going to be a little bit extra, okay? So again, to do your box method, if I go and find the degree here, my degree is equal to 1. So my dimension for that is going to be a 2. Sorry, I just wanted to see what that pen looked like. Okay, over here, this one, my degree is 2. That means my dimension is 2 plus 1, which is 3. And so our box for this one is a 2 by 3 box. It's a little bit different than what we've been doing. So it doesn't really matter how you put it on here. I'm just going to do this. So there's my 2 rows. Here's by 3 columns. The only thing that matters is that this has to go with the 3 boxes. So you'd want to put 2x squared, 3x, and minus 5 up here. And then on this side, you put the 6x plus the 5. So I go and I write this down. Okay, now I do my multiplication. 6 times 2 is 12. X times x squared would be x cubed. Negative 3 times 6 is negative 18. X times x is x squared. 6 times negative 5 is negative 30. And then we just have an x with it. 5 times 2 is 10. And then we have an x squared. 5 times negative 3 is negative 15x. 5 times negative 5 is negative 25. Again, what we're hoping happens when you do this, and kind of what the purpose is that you end up with all of these diagonals that end up combining. So look at that. Okay. Simplify it. So the 12x cubed is by itself, but we have a negative 18x squared and a 10x, so that becomes negative 8x squared. We have a negative 15x minus 30x, which would be negative 45x. And then we have that negative 25. So that would be my final answer there. Okay. So you can use a box just like this. You can use the distributive property. So I'm going to use the distributive property, not the box for this one. You could do a box. In that case, if you're going to be doing the box, if you want to try it on your own, the box, it's going to be a 3. Oh my goodness. A 3. I have no clue what's going on here. Okay, so again, I'm going to use the distributive property this time, but if you were going to use a box, this would be degree 2, so the dimension would be 3. This would be a degree 2, which would make its dimension 3. So you would need to make a 3 by 3 box if you were doing it that way. But again, it's very doable. You're just going to have to add a little bit more to it than maybe what we're used to. Okay, so I said I'm going to do the distributive property. So what I'm going to be doing is taking this term and multiplying it by these 3. So I take my 2y cubed and I'm multiplying it by 3y squared minus, 2y squared times 3y squared minus 5y plus 2. Then I move on to my next term, which is this 3y, and I'm doing the same thing. I need to multiply it by all 3 terms. And then my last one is looking at this -1, going to all 3 terms. So I say -1 times 3y squared minus 5y plus 2. Okay, so I go and I multiply these out. Okay, 2y squared times 3y squared. And I'm getting 6y to the 4th. 2y squared times -5y, I would get negative 10y cubed. 2 times 2y squared is 4y squared. Move on to my next little section. 3y times 3y squared is 9y cubed. 3y times -5y is -15y squared. 3y times 2 is 6y. Move on to my next groups. Negative 1 times 3y squared is negative 3y squared. Negative 1 times negative 5y gives us a positive 5y. Negative 1 times 2 is just a negative 2. So again, kind of the issue with this is that you kind of have to search to see what combines as opposed to the box where it usually nicely lines up. Not a big deal, but it just adds an extra step. Okay, so the y squareds go together. The y's go together. And the numbers by itself. So if I take 6y to the fourth, that just stays by itself. It can't combine with anything. Move on to the y cubes. We have negative 10y cubed plus 9y cubed. That would just be a negative y cubed. I move on to the purple ones. So this one, this one, this one. 4 minus 15 minus 3. So if I take 4 minus 15 minus 3, I get negative 14 y squared. Move on to my blues, or sorry, not my blues, my yellows. So 6y plus 5y, I get 11y. And then that negative 2 just stays. So 6y to the fourth minus y cubed minus 14y squared plus 11y minus 2. Okay? There's a lot going on there. Take it step by step. Take each term of the first polynomial times the second polynomial and then simplify it. Okay? And then you combine your like terms. Okay? So, move on now then into the back. We just have a lot more practice problems. Okay? So I'm probably going to do maybe 2 more with the box, 2 or 3 more. Otherwise, I'll just go into the distributive property some more. I know it's probably getting long sitting here, but I want to make sure you have enough practice here so that when you get on your own to the assignment, you feel pretty confident that you can do this. So I'm going to do the box for this one. When I look here, this is degree 2, which means my dimension has to be a 3. The dimension of the box is 3. Over here, I have degree 3, which means my dimension has to be a 4. And so this is going to be a 3 by 4 box. Okay, so squeeze it in here. I'm going to have 4 columns, 3 rows. Again, it really doesn't matter as long as you set it up correctly. So the one that goes on the side with the 3 rows has to be the one that had the dimension of 3. So that would be like the 6z squared, negative 5z, and the negative 2. And then the one that had degree 3 goes along the top. Now, you will notice there are only 3 terms right here, okay? But we have 4 spaces. What I do is I put my highest degree here. I see that I'm missing z squared. So that is going to go as a 0 z squared right here. I have a negative 2z here, and then I have a minus 4. If you forget to put the 0 in, that's okay, but what's going to happen is your diagonals aren't going to match up. You're going to have to search for your terms that combine. Okay? So now you just go and do the same. Okay, so I deleted the original audio that went with this. What it's going to do is just go through each box. So I took 0z squared times 6z squared and get 0z to the fourth. Negative 2z times 6z squared. 6 times negative 2 is negative 12. Z squared times z is z cubed. I take a negative 4 times a 6 and I get negative 24, and then you have the z squared. I have negative 5 times 3 and I get negative 15 z to the fourth. I now have a 0z squared times a negative 5z. 0 times 5 is 0. Z squared times z is z cubed. I have a negative 2z times a negative 5z. So negative 2 times negative 5 is positive 10. Then z times z is the z squared. I take negative 5 times negative 4 and get 20z. I take a 3 times the negative 2 and get negative 6, and then I have z cubed. 0z squared times negative 2 is just 0z squared. Negative 2z times negative 2 is negative 4z, and then negative 4 times negative 2 is 8. One thing about this here is that your diagonals should be lining up, so those are terms that you can combine. What was I going to say? The zero is not necessary there, but by putting them in, it allows your diagonals to still line up. If you didn't have the zeros in there, you would just have to be finding your like terms by making sure you had everything in there. Thank you. Okay, so we get an 18z to the 5th. Negative 15 plus 0 is going to be just negative 15z to the 4th. Negative 6 plus 0 plus negative 12, we're going to get negative 18z cubed. Moving on to the purple diagonal, 0 plus 10 minus 24. 10 minus 24 would be negative 14. 4 plus 20 is 24. And then we have that plus 8. Let's see if I can move that a little bit. Okay, so you get 18z to the 5th minus 15z to the 4th minus 18z cubed minus 14z squared plus 24z plus 8. There's a lot going on there. Okay, and really it's up to you if you want to do the box, if you want to do distributive property. Completely up to you. Okay, so 29, I'm going to jump back and do my distributive property. If you want to do the box, you can. But here's going to be a dimension of 4. Here's a dimension of 3. So you can do the box, but just be aware, if you put the zeros in there, dimension of 4, dimension of 3. I'm going to just do the distributive property. So each of these terms go to each term in the second one. I break apart that first polynomial, 3b cubed. I take that times 2b squared minus b minus 9. I go on to the negative 4b next and multiply that by 2b squared minus b minus 9. And then I take that negative 7 and I take it times 2b squared minus b minus 9. And so this is the one that I split up. Here's the one that's sticking together. And all we're doing is making sure that every term distributes through. So 3 times 2, we'd get 6. B cubed times b squared, we get b to the 5th. 3b cubed times negative b, we're going to get negative 3b to the 4th. 3b cubed times negative 9, I get negative 27b cubed. Okay, I move on to my next thing. Negative 4b times 2b squared. Negative 4 times 2 gives us negative 8. B times b squared is b cubed. I take negative 4b times negative b. So negative 4 times negative 1, that would become a positive 4. And then b times b is b squared. I take a negative 4b times negative 9. Negative 4 times negative 9 is a positive 36. And we have a b. And then that last one over here, negative 7 times 2 is negative 14, and then we have a b squared. We have a negative 7 times a negative b, which gives us a positive 7b, and we have a negative 7 times a negative 9, which is a positive 63. Okay? Now combine your like terms. So b to the 5th, we only have that one. B to the 4th, we only have one of that as well. So we get 6b to the 5th minus 3b to the 4th. Move on to the b cubes. So here's a b cubed, here's a b cubed. Negative 27 minus 8. If we simplify that, negative 27 minus 8, we get negative 35. B cubed. If we take 4b squared minus 14b squared, we get minus 10b squared. If we take 36b plus 7b, we get 43b. And then you're just left with that 63 on its own. Okay? So I get it's a lot. There's a lot here. If you need to pause the video, pause it, get it written down, come back to it. Okay? You can do that. We have just a few more examples left. I'm probably going to stick to distributive property, just this horizontal method, for at least 5 of the last 6 here. But if you want to do the box, feel free. I don't want to have you sitting here waiting too long, and it takes me a little longer to do the box. Okay? So number 14. This is something that many people... Okay, so the h plus 7 squared, what a lot of people want to do is just distribute that exponent to both terms like that and get h squared plus 49. But that is not what you need to do. What we need to do is expand that. So h plus 7 squared is the same as h plus 7 times h plus 7. Once you have that expanded, you can just either use the box method, the 2x2 box, or do that distributive property we've been working on. I choose to do the box here, so I take h plus 7 times h plus 7. I go and I multiply through, and so you can see me do it here. And then I combine this, the diagonal right there, h squared plus 14h plus 49 is my final answer there. So just be careful if you ever see like a binomial that's being squared like that you can't just square both terms. You actually need to take it, do a box multiplication or distributive property, and get your answer that way. Okay, so number 19, same thing. You're going to take 5t minus 2 times 5t minus 2. So if I break apart that first one, make sure it multiplies through to both terms. This one's a little funny because this thing ended up being the same. So I broke that one apart. And then this right here is the one that stuck together. Distribute through. 5 times 5 is 25. T times t is t squared. 5 times negative 2 is negative 10t. Negative 2 times 5 is negative 10t. Negative 2 times negative 2 is a positive 4. So I get 25t squared minus 20t plus 4 as my final answer for that one. Okay. We only have 4 left. Stick with me here. Okay. So the only difference with these ones at the bottom, they're both just binomials being multiplied by binomials. So the whole thing is 2 by 2 boxes is what you'd be making. The difference is that we have 2 variables. So when I get multiple variables, I don't really like doing the box. It still works. Like you're still going to end up the same, but the diagonals don't work out quite as nicely as they do when all the variables are the same. So just for that purpose, I'm going to do the remaining by using just the distributive property. Okay, so I'm going to break apart that first term and multiply it by the second term. So x has to be multiplied by the 2x minus y. That negative y has to be multiplied by that 2x minus y. So again, this is the one I broke up. This is the one that's being multiplied by that stayed together. X times 2x, we get 2x squared. X times negative y, we would get negative x times y. The variable, like the exponents don't change at all, we just have an x and a y. We move on to the next one, we get a negative y times a 2x, and so I get negative 2xy. I take a negative y times a negative y, and I get a positive y squared. So negative 1 times negative 1 is positive 1, y times y is y squared. Now you do still have these terms that are combining in the middle. It's xy. So 2x squared, we have negative 1xy minus 2 more xy's. We would be at negative 3 xy's. And then we have that plus y squared. Okay. Next one, I take my 3y times the 6y plus 7z. And then I take the negative 2z times 6y plus 7z. So 3 times 6, we get 18. Y times y is y squared. 3 times 7 is 21. Y times z, we just leave as yz. The next little section, we have a negative 2z times 6y. Negative 2 times 6 is negative 12. And then we have a y and a z. You could put it as zy, but just remember that those two middle terms are going to then still combine. And then we have negative 2 times 7, which would be negative 14, z squared. The last step is going to be to combine your like terms. So 18y squared, 21 minus 12 is going to be 9y squared. Or sorry, yz, not y squared. And then we get minus 14 z squared. Okay, sorry about that. Okay, here's my final answer. Okay, the last two, I want you to just do on your own. So if you want to pause the video, you could. If you want to just keep this rolling, and those of you that want to try it on your own, so everybody should try it on your own, but if you want to pause the video, you can, and then show the answers. Otherwise, the answers will show up here in just a minute or a second. Make sure that you make sure that you know how to do this. So this one you get 40w squared minus 28wx minus 24x squared. Number 26, you'd end up with 4q squared minus 25r squared. That one's kind of interesting because the middle terms cancel. So please make sure that you go through those either right now as you start your homework. Okay, I will check tomorrow to make sure that you did those two problems. I'll check it right at the start of class that you showed your work for those. Okay. One thing I just wanted to remind you of, tomorrow we will have a quiz over the section 8-1. So adding and subtracting polynomials and then multiplying a monomial times a polynomial. That quiz will be tomorrow. So please make sure that you've completed your homework on it and that you know what you're doing. If you don't, please come in and get help tomorrow morning. I will be here. Yeah, so you can log into Alex. Your assignment should be open. Another thing that opened today is your topic goals for this week. So don't forget that you have 15 topics that are due next Monday. Okay? Thank you. Have a good day. See you tomorrow.